Today we're looking at how to factor the sums and differences of cubes. So again, we have binomials, and we're looking at how to factor the sums. Sums, remember, is the addition of two terms, and the difference is subtraction of two terms. Now, when you do the a cubed plus b cubed, this can be factored as a plus b times a squared minus ab plus b squared. And to factor a cubed minus b cubed, the same terms, but the signs are different. We have a minus b times a squared plus ab plus b squared. Now one phrase that or one word, shall I say, that I remember for this is the word soap, and it's the phrase same, opposite, always positive. So if we look at this, the first term will always be the same, the second one will be the opposites, and the last one's always positive. So opposite of positive is negative. So like on our second one, this was a cubed minus b cubed. This will be the same term. This will be the opposite, and this one's always positive. My younger sister taught me that at one time, or showed me. I just memorized those formulas in the past, but that kind of helps me determine if I had the right sign with that. Now let's look at numbers 1 through 8 in this lecture. And our first one here, we have x cubed minus 64. And if I look at this, isn't the same thing as x cubed minus 4 cubed, because 64 is 4 times 4, which is 16, and 16 times 4 is 64. So this is a difference of squares. I can say, look, this is x minus 4 times the square of the first one. I don't really memorize the formula. I just say, look, drop the cubes, so that's x minus 4, square the first term, multiply the two terms, 4 times x is 4x, and 4 times 4 is 16, so squared our last term. Now remember, our signs are the same, opposites, and always positive, and that is our answer for this binomial. Now I want to check my work for this first one. So when I check it, I want to distribute the x, so that's going to be x cubed plus 4x squared plus 16x. I was doing the 4 already. And then we have negative 4x squared minus 16x minus the 64. And as you see, the middle two terms will cancel out like they did back in the difference of squares. And here we have the a cubed minus 64. Actually, x cubed minus 64, which is what we had up there. Okay, so this checks out to be great. Now how about our next one? How about 8y cubed plus 1? So first I'll look for the GCF. The GCF, well, this is a 1, so the GCF is just 1. I can't factor that any further. And here I have a plus in here, so that's a sum, and I believe these may be cubes. Let's try to check this out. 8 is what? 2 times 2 times 2. That's 2 cubed. So this is the same as 2 times y, the quantity cubed. And isn't 1 times 1 times 1? So that's going to be 1 cubed. So when I factor this, first off, drop off these cubes. That's 2y plus 1. Square the first term. 2y times 2y is 4y squared. Multiply the two terms, that's 2y, and square the last term. 1 times 1 is 1. My signs, once again, same, opposite, always positive, and so this is my answer altogether. Now be careful, do not do this. Some people say, oh look, since this is 2y cubed plus 1, this would be 2y plus 1 cubed. Again, I say do not do this. This does not work at all. I mean, if I looked at this, isn't this 2y plus 1 times 2y plus 1 times 2y plus 1, because I'm cubing it. And if you go ahead and expand this, when you go all together, this would be 8y cubed. Oh good, that's what it started with. But then your next term would be plus 12y squared, and then it'll be plus the 6y, and then it'll be plus 1. See, these middle two terms is not what's in the original problem here. So again, when you look at this sum of cubes, you must use this technique in order to work with this factorization. Let's look at numbers 3 and 4. You can pause the tape if you want, try these on your own, or if not, we can work on these together. Our next one here, this is a binomial, is two terms. Again, first look for the GCF. I see 27 is 3 times 3 times 3. 3 does not go into 8, so it can't be broken down anymore. But what I see, I don't know if you see this also, 27 is 3 cubed, and 8t cubed is, let's see, 2 cubed is 8, and t cubed is t cubed, so it's going to be this quantity cubed. Make sure when there's a coefficient, you look and see what is the cubic term. Some people leave this 8 in there, and that's going to mess up the entire picture for us. Remember, 8t cubed is the same as 2t quantity cubed. So when you look at this, see, first we drop off the cube, so it's 3 minus 2t. Then I'll square the first term, multiply the 2, 3 times 2t is 6t, and square the last term. 2t times 2t, 2 times 2 is 4, and t times t is t squared. Same, negative, opposite, positive, always positive, plus. And that is our answer for this problem. Now, most of the time, not all the time, but most of the time this cannot be factored any further. Yes, this is a trinomial. If you wanted to check this out, what's 4 times 9? That's 36. Are there two numbers that will multiply to 36 and add up to a positive 6? Not a negative 6, but a positive 6 with this. So, I mean, if I looked at this, it's 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. Do any of these add up to a positive 6? Answers no. So this cannot be factored any further. So like I said, most of the time, probably about 95% of the time, this will not be able to be factored any further. Number 4, 2y cubed plus 54. So again, look for the GCF. This one does have a GCF of 2, doesn't it? So it has a GCF other than 1. So we must factor that out. And when I factor out the 2, we have 2 times the quantity x, or y cubed, plus 27. And this is a sum of cubes, right? So whenever you have a pair of two terms, see if it's a sum of cubes or a difference of squares or difference of cubes. And if it's one of those, it can be factored. Okay, so I'm not going to forget this 2. Bring it down. Then I'll drop off the cubes, so this will be y plus 3. Square the first term, y times y is y squared. Multiply the 2, that's 3y. And square the last term, 3 times 3 is 9. Same, opposite, always positive. And that is our answer. Okay, how's it coming along? Hopefully all is well. Let's try 5, 6, and then we have 7 and 8. So let's see, for number 5, we have 8x cubed plus 1,000. Now right now I see two cubic terms. 8 is 2 times 2 times 2, and 1,000 is 10 times 10 times 10. But I also see a GCF in here. I always try to do the GCF so I can kind of get rid of that at the very beginning instead of worrying about that at the end. See 8 and 1,000. Doesn't 8 go into 1,000? If you checked on your calculator, you'll say that 1,000 divided by 8 is 125. So when I factor out my 8, this would be 8 times this x cubed plus 125. And 125, by the way, is 5 cubed, isn't it? 5 times 5 times 5. So here we'll also have a sum of cubes. And again, don't forget that 8. Keep bringing down that GCF as far as you can. And when I do this, let's see, x cubed, again, drop off those cubes. It's x plus 5. Square the first term. Multiply the 2. And square the last term. So here we'll have x squared minus 5x plus 25. That's our answer. Another one. C cubed minus 1/8. Now I'm looking at fractions here. Be careful with this. See, 8 is 2 times 2 times 2, isn't it? So this would be the same thing as c cubed minus 1/2 cubed. So since 2 times 2 times 2 is 8, 1/2 times 1/2 times 1/2 is 1/8. So this is also a difference of cubes. And just like we do in the previous, we'll go c minus 1/2, drop off those cubes, square the first term, c times c is c squared, opposite sign plus, 1/2 times c is 1/2 c, always positive, 1/2 times 1/2 is 1/4. Now in this case, now remember back in a previous video, we took this 2, put it in front of the c, right? I'm putting this in red because this is what not to do. Don't do this. When you work with fractions, keep them as fractions. You know, when the numbers are not fractions at the beginning and we're working with fractions, then we can do that manipulation with it. But keep these fractions in here. Be very careful of what you do with it. Okay, our last two problems for today, 7 and 8. So for number 7, again, look for the GCF. The GCF of 3x to the 5th and 3x squared. They both have a 3, so we can pull out a 3. Choose a different color here. 3. And they both have an x squared. They both have 2 x's in here. So when I pull out a 3x squared or 3x to the 5th, we x cubed, don't we? And 3x squared, when I pull out a 3x squared from it, we have this minus 1. Don't forget 3x squared divided by 3x squared is this 1. We need 2 terms with it since we started with 2 terms. Now can I factor this any further? And as I see, we have x cubed, that's a cube. And 1 is 1 cubed, that is also a cube. So we have a difference of cubes within here. So again, in my answer, I'll pull down my GCF. We'll drop those cubes. So I have an x minus 1. We'll square the first term, change the sign, multiply the 2, always positive, and 1 times 1 is 1. And this is what we get. How about number 8? Number 8, we have x to the 6 plus 1. Now I haven't done with powers of 6, but we have done cubes with this. Now is x to the 6 something cubed? Now remember, when you do a power to a power, you just multiply it. So isn't x squared cubed? That's the same thing as x to the 6th power, because 2 times 3 is the 6. So this is also a sum of cubes. This is just x squared cubed plus 1 cubed for us. So the first thing we'll do is we'll drop off the cubes. So this will be x squared plus 1. We'll square the first term. X squared times x squared is x to the 4th. We'll multiply the 2x squared times 1 is x squared. And we'll square the last one as a plus 1. Same, opposite, always positive, and this is what we'll have. One thing that we need to check and see if this is factored all the way too. We want to make sure this is our final answer. Now x squared plus 1, that's a sum of squares. We can't factor that any further. And then x to the 4th minus x squared plus 1. Like I said, most of the time this cannot be factored in. Here it cannot either. So yes, this is our final answer for this problem. If you have any questions, please let me know. Take care.